What if everything we thought we knew about the dawn of civilization was just the tip of the cosmic iceberg? Picture a time so distant, so unfathomably ancient, that entire cultures may have risen and fallen among the stars long before humanity even took its first steps on Earth. This isn't science fiction, it's one of the most tantalizing mysteries in the universe. The possibility of civilizations that existed billions of years ago, hidden in the shadows of time. What would those first societies have looked like? Could they have mastered technologies beyond our wildest dreams? And most haunting of all, did they leave behind traces of their existence, waiting for us to uncover? The cosmos is old, so old that our entire recorded history is just a fleeting moment in its grand timeline. While we've only recently begun to piece together the story of human civilization, the universe had a 14 billion-year head start. That's more than enough time for entire civilizations to emerge, evolve, and perhaps even vanish without a trace. Some scientists believe the conditions for intelligent life may have existed far earlier than we ever imagined, perhaps even in the universe's fiery youth when the first galaxies were still forming. Imagine a civilization that thrived when the cosmos itself was still in its infancy, harnessing energies we can't even comprehend. That's exactly what we're diving into today. We'll explore 30 astonishing theories about the universe's first civilizations, ideas that stretch the limits of what we thought was possible. From ancient mega structures hidden in deep space to cosmic artifacts that defy explanation, these theories will challenge everything you assume about life, time, and our place in the universe. Some will sound like pure wonder, while others might send a chill down your spine. And who knows? By the end, you might just look up at the night sky and wondered, are we really alone? Or are we simply the latest chapter in a story that began eons ago? The first theory takes us into the realm of the truly unimaginable. What if we're not the universe's first attempt at intelligence? Some researchers speculate that long before Earth even formed, an ancient civilization might have risen to dominance in the early cosmos. These hypothetical beings, often called the precursors, could have existed billions of years before us, harnessing technologies so advanced they might as well be magic to our modern eyes. Think about this. The universe was born around 13.8 billion years ago, and the first stars ignited roughly 100 million years later. That's an incomprehensible stretch of time, enough for entire civilizations to emerge, flourish, and disappear long before our solar system was even a swirling cloud of dust. Some scientists argue that if life arose even once in those early eras, it could have had a staggering head start, evolving into something far beyond our current understanding. So, where's the evidence? Some astronomers point to strange cosmic anomalies, like unexplained structures in deep space that don't fit natural explanations. Take, for example, Tabby's star, a distant sun that dims in bizarre, irregular patterns, leading some to speculate it might be surrounded by an alien megastructure. Then there are the odd radio signals and unexplained energy signatures that occasionally flicker across our telescopes, hinting at something we can't yet decipher. Even more unsettling is the idea that these precursors might have left behind artifacts, relics of their existence hidden in plain sight. Ancient ruins on distant planets, dormant machines buried in asteroids, or even coded messages embedded in the fabric of space itself. If true, uncovering such relics could rewrite not just human history but the history of the entire universe. But here's the haunting question: if they were so advanced, where are they now? Did they transcend into some higher state of existence? Did they perish in a cataclysm beyond our comprehension? Or are they still out there, watching silently, waiting for us to stumble upon their legacy? The answers might be out there if we dare to look. This brings us to an unavoidable question, one that haunts every conversation about ancient cosmic civilizations. If the universe truly hosted advanced societies billions of years before us, why haven't we found undeniable proof of their existence? It's the same enigma at the heart of the Fermi Paradox, which asks a deceptively simple question: where is everybody? The eerie silence of the cosmos clashes with the staggering probability that intelligent life should be out there somewhere. When we apply this to the precursor theory, the mystery only deepens. One chilling possibility is that these early civilizations didn't survive. Imagine a species so advanced they could reshape galaxies, yet still vulnerable to the same forces that threaten us today: war, resource depletion, or unchecked environmental collapse. Some researchers speculate that technological maturity might come with a fatal flaw. The easier it becomes to manipulate the fabric of reality, the higher the chance of catastrophic miscalculation. A single experiment gone wrong, a weapon too powerful to control, or an AI spiraling beyond comprehension could erase an entire civilization in an instant. If that's true, the universe might be littered with the graves of societies that reached too far, too fast. But extinction isn't the only explanation. What if they didn't vanish? What if they evolved beyond our ability to perceive them? Think about how a colony of ants might interpret a skyscraper or a smartphone. To them, it would seem like magic, or perhaps they'd never notice it at all. Some theorists argue that advanced civilizations could transcend physical form, uploading their consciousness into quantum substrates or higher dimensions we can't access. They might exist all around us, as invisible to our senses as radio waves are to the naked eye. Then there's the zoo hypothesis, the idea that we're being deliberately left undisturbed, like a nature preserve. If precursors still exist, they might be observing us from a distance, waiting for humanity to reach a certain level of maturity before making contact. It's a humbling thought. We could be living in someone else's carefully curated experiment, unaware of the boundaries they've set around us. Or perhaps the answer is even stranger. What if the evidence is right in front of us and we just don't recognize it? Cosmic archaeology is still in its infancy. We might be mistaking alien megastructures for natural phenomena, or overlooking coded messages hidden in the constants of physics. The universe is vast and our tools are limited. The traces of ancient civilizations could be etched into the fabric of space-time itself, waiting for the day we develop the eyes to see them. So the silence isn't necessarily emptiness. It might be a puzzle we haven't solved yet, a message written in a language we're only beginning to decipher. Every unexplained cosmic anomaly, every strange signal from the void could be another piece of the story. And if we keep searching, who knows what we might find? The truth could be closer than we think. What if the greatest leaps in human civilization weren't entirely our own doing? This brings us to the second theory, the ancient astronaut hypothesis, a provocative idea that suggests extraterrestrial visitors may have shaped human history in ways we're only beginning to uncover. Proponents of this theory point to eerie artifacts, enigmatic texts, and colossal monuments that defy conventional explanations, all hinting at the possibility that we were not alone in our ascent to knowledge. Take the Nazca lines, for instance, those massive geoglyphs etched into the Peruvian desert, some stretching over 600 feet across. These intricate designs, best appreciated from high above, depict animals, geometric shapes, and even what some interpret as humanoid figures. The puzzling part, they were created over 2,000 years ago by a culture with no known technology for flight. How did they achieve such precision without an aerial perspective? Could these sprawling artworks have been meant as signals or landing markers for beings who could view them from the sky? Then there's the Sumerian civilization, often hailed as the cradle of human writing and governance. Their texts speak of the Anunnaki, deities who descended from the heavens to bestow knowledge upon humanity. These accounts describe advanced technologies, celestial vehicles, and even genetic manipulation, details that echo startlingly close to modern concepts of space travel and bioengineering. One particularly compelling artifact is the Baghdad Battery, a clay jar dating back 2,000 years, found with components resembling a primitive galvanic cell. Was it merely a ceremonial object or evidence of lost scientific understanding, perhaps even imported from elsewhere? Skeptics argue that these mysteries can be explained through human ingenuity and cultural symbolism. But the sheer volume of similar accounts across disparate ancient cultures raises eyebrows. The Dogon people of Mali, for example, possessed detailed astronomical knowledge of Sirius B, a star invisible to the naked eye centuries before telescopes confirmed its existence. The Mahabharata, an ancient Indian epic, describes flying machines called vimanas and weapons capable of destruction, eerily reminiscent of nuclear blasts. Could these be mere mythological flourishes or fragmented memories of encounters with something beyond our world? The ancient astronaut hypothesis doesn't just challenge our understanding of history, it forces us to reconsider humanity's place in the cosmos. If these visitors existed, what was their purpose? Were they benevolent guides accelerating our evolution, or were they conducting experiments, leaving behind clues for us to discover when we reached a certain level of technological maturity? And if they're still out there, watching silently as we piece together their legacy, what might they want from us now? The answers, if they exist, lie buried in the artifacts they left behind, waiting for us to look closer. Mainstream science has long treated the ancient astronaut hypothesis with skepticism, dismissing it as pseudoscience or imaginative speculation. But the divide between conventional academia and alternative theories isn't as rigid as it might seem. While most archaeologists attribute anomalies like the Nazca lines to human ingenuity and cultural symbolism, a growing number of astronomers and physicists are willing to entertain more unconventional possibilities, especially as new discoveries challenge our understanding of what's out there. Take Oumuamua, the mysterious interstellar object that streaked through our solar system in 2017. Its peculiar shape, long and cigar-like, along with its unexpected acceleration, left scientists scrambling for explanations. Harvard astrophysicist Avi Loeb famously suggested it could be an artificial object, perhaps a light sail or debris from an advanced civilization. While most researchers proposed natural explanations like outgassing from a comet, the debate itself revealed something fascinating. Even the most conservative scientists are forced to grapple with the unknown when faced with data that defies easy classification. Skeptics argue that extraordinary claims require extraordinary evidence, and so far, no smoking gun proves ancient extraterrestrial contact. They point out that human creativity and error can account for many so-called anomalies. The Baghdad Battery, for instance, might have been used for electroplating rather than as a power source, and the Dogon's knowledge of Sirius B could stem from cultural contamination by early anthropologists. These counterarguments are compelling, but they don't entirely close the door on the conversation. What's intriguing is how technology is reshaping the debate. Projects like SETI and breakthroughs in exoplanet research have shifted the goalposts. We now know the universe teems with potentially habitable worlds, and the odds of other intelligent life seem higher than ever. Meanwhile, advancements in AI and data analysis allow us to scan ancient texts and artifacts for patterns we might have missed before. Could undiscovered clues lie buried in millennia-old manuscripts or hidden within the cosmic microwave background? The real tension lies in how we define evidence. For proponents, the absence of definitive proof doesn't negate the possibility, it just means we haven't found it yet. For skeptics, the burden remains on those making the claim, yet both sides share a common ground: curiosity. Whether it's a physicist analyzing Oumuamua's trajectory or an archaeologist re-examining Sumerian tablets, the hunger to uncover the truth drives the conversation forward. And in that shared pursuit, even the wildest theories find a place at the table of scientific inquiry. perhaps the most compelling aspect of this debate isn't who's right or wrong, but how it reflects our own evolution as a species. Every time we reconsider an ancient mystery or a cosmic oddity, we're forced to confront the limits of our knowledge and the tantalizing possibility that the universe still has secrets waiting to be revealed. What if we're not the first advanced civilization to call Earth home? This is the spine-tingling premise of the Silurian hypothesis, the idea that industrial societies might have risen and fallen on this planet millions of years before humans ever walked the land. Named after a fictional prehistoric race from Doctor Who, the theory doesn't involve lizard people or sci-fi tropes. Instead, it's a serious scientific thought experiment. If an industrial civilization existed in Earth's deep past, how would we even know? Geologists searching for answers face a daunting challenge. Time erases almost everything. Imagine a city buried not just under layers of dirt, but under hundreds of millions of years of tectonic shifts, erosion, and geological upheaval. The pyramids of Egypt, for all their grandeur, would be reduced to faint mineral traces in the rock record after just 10 million years. Now stretch that timescale to 50 or 100 million years, and the evidence becomes vanishingly thin. That's where techno-signatures come in, subtle chemical or physical traces left behind by advanced activity. Think of the way our own industrial society has altered the planet. Microplastics embedded in sediment, radioactive isotopes from nuclear tests, or sudden spikes in atmospheric carbon. These markers might linger far longer than skyscrapers or smartphones. Scientists scanning ancient rock layers for anomalies have found a few intriguing clues. The Paleocene-Eocene thermal maximum, a period 56 million years ago, shows a massive carbon spike eerily similar to modern climate change. Could it have been natural or something else? But here's the catch. The Earth is a master of recycling itself. Plate tectonics literally grinds continents into dust over eons. The farther back we look, the more the planet's surface has been churned, melted, and rewritten. Even if a civilization burned fossil fuels or built sprawling cities, their remains could now be scattered across the ocean floor or pressed into metamorphic rock, utterly unrecognizable. Perhaps the most haunting question isn't whether evidence exists, it's whether we'd recognize it if we saw it. Future geologists studying our layer might spot the plutonium-239 from nuclear tests and call it a natural radioactive fluke. Our concrete jungles could be mistaken for strange mineral deposits. If we're struggling to find traces of hypothetical past civilizations, how many might have slipped through the cracks unnoticed? The Silurian hypothesis forces us to confront a humbling truth. Civilizations, no matter how advanced, might be fleeting blips in Earth's vast timeline. If others came before us, their rise and fall could hold urgent lessons about resilience, sustainability, and the fragile thread that ties any society to its planet. And if we're truly the first, that might be the most unsettling possibility of all, because it means the great filter of self-destruction still lies ahead of us. The parallels between our current climate crisis and the fate of hypothetical ancient civilizations are impossible to ignore. If an industrial society did rise millions of years before us, what if their collapse wasn't caused by war or cosmic disasters, but by the same environmental missteps we're making today? The Earth's geological record holds eerie warnings in layers of sediment and ice, telling stories of abrupt climate shifts that reshaped the planet long before humans existed. Consider the Paleocene-Eocene thermal maximum, a period 56 million years ago when global temperatures skyrocketed by up to 8 degrees Celsius. The cause, a massive release of carbon, possibly from volcanic activity or methane deposits. Sound familiar? Today, we're replaying that same script, pumping greenhouse gases into the atmosphere at an unprecedented rate. If another civilization once triggered a similar climate catastrophe, their ruins wouldn't just be buried, they'd be a cautionary tale written in isotopes and fossilized mud. But here's what's truly unsettling. The Earth recovered from the petum, but it took over 100,000 years. For any society caught in that kind of upheaval, recovery might not have been an option. Crop failures, extreme weather, rising seas, these aren't abstract threats. We see their echoes in abandoned cities like Tikal or Anchor, where overexploitation of resources contributed to collapse. Now stretch that scenario across geological time. A civilization reaching industrial heights only to crumble under ecological disaster wouldn't leave behind grand ruins, just subtle chemical scars, invisible until someone knew where to look. The kicker, we might be creating those same scars right now. Microplastics sinking into ocean sediments, radioactive particles from nuclear tests, the unmistakable spike in carbon isotopes. These are the fingerprints we're stamping into the planet's future record. Future geologists, if they exist, might one day study our layer and wonder, did they see it coming? This raises a darker question. Could climate collapse be the universe's great filter? A trap that every intelligent species stumbles into once they unlock industrialization. If so, the absence of ancient civilizations might not be a mystery, just a grim pattern. The universe could be littered with planets that briefly flared with intelligence before succumbing to their own success. Yet there's a sliver of hope. Unlike those hypothetical precursors, we have something they might not have had: awareness. We can read the warning signs in ice cores and coral reefs. We know the stakes. The Silurian hypothesis isn't just a thought experiment, it's a mirror. Whether or not we're Earth's first advanced civilization, we have the chance to be its last. The choice is written in every ton of carbon we don't emit, every ecosystem we preserve. The universe might be watching to see if we learn what others couldn't. What if the most advanced civilization wasn't one that conquered nature, but became one with it? Enter the Gaia hypothesis, the idea that a planet's biosphere acts like a living, self-regulating organism. Now take that concept even further. Imagine a civilization so deeply intertwined with its world that it no longer stood apart from the ecosystem, but functioned as part of its very fabric. This isn't just sci-fi fantasy. It's a radical theory that challenges our obsession with megacities and space colonies, proposing instead that true advancement might mean dissolving the line between biology and technology. Think of Earth's own biosphere, a dizzyingly complex web where everything from bacteria to weather patterns plays a role in maintaining balance. The Gaia hypothesis, first proposed by scientist James Lovelock, suggests our planet isn't just a rock hosting life, but a dynamic system that actively regulates itself to sustain habitability. Now apply that to intelligence. Could a civilization reach such harmony with its environment that it ceased to be separate from it? Picture vast organic networks where cities grow like forests, energy flows through photosynthetic circuits, and waste doesn't exist because every output becomes another system's input. Sci-fi has flirted with this idea for decades. In books like Solaris or films like Avatar, we see worlds where intelligence isn't confined to individual beings, but distributed across entire ecosystems. The Pandora Moon, with its neural connections between trees and creatures, offers a glimpse of what a Gaia civilization might resemble: a planet that thinks, responds, and evolves as a unified whole. Even closer to home, consider the way fungal mycelium operates, linking plants in underground communication, networks so sophisticated scientists call it the Wood Wide Web. Scale that up to a planetary level and you start to see the blueprint for something extraordinary. But here's the twist: we might already have living proof that such civilizations are possible. Take Earth's oceanic ecosystems, where cephalopods like octopuses demonstrate problem-solving intelligence so alien to our own. It hints at entirely different evolutionary paths to smarts. Or consider termite mound structures built without blueprints, regulating temperature and humidity with precision that rivals human engineering. These aren't just curiosities, they're proof that advanced systems can emerge from decentralized biological intelligence. The haunting question isn't whether a Gaia civilization could exist, it's whether we'd even recognize it as a civilization at all. Our search for alien life often focuses on radio signals or Dyson spheres, artifacts that mirror human technology. But what if the most advanced societies leave no such traces? A planet that achieves perfect symbiosis might appear from space as little more than a lush wilderness. Its cities could resemble coral reefs or old-growth forests, its technology indistinguishable from natural processes. That raises a thrilling possibility. Exoplanet surveys have already spotted worlds shrouded in biosignatures, oxygen, methane, vegetation like spectral lines. We celebrate these as potential cradles of life. But what if some of them aren't just hosting life, but are life? Conscious, self-aware worlds where every river, every storm, every root system is part of a vast, sentient network. If that's true, the greatest civilizations in the universe might not be the ones broadcasting their presence. They might be the ones quietly thriving, having mastered the ultimate technology, becoming one with their home. For humanity, the implications are profound. Our path has been defined by extraction and expansion, but the Gaia theory suggests another way: integration. Instead of domes on Mars, imagine adapting ourselves to flourish within Earth's existing systems. Instead of fighting climate change, imagine partnering with it. The universe may hold civilizations millions of years ahead of us, but perhaps their greatest lesson isn't how to leave our planet, but how to truly belong to it. What if the most advanced civilizations didn't build towering cities or sprawling megastructures, but instead learned to transcend the very fabric of reality? This is the mind-bending premise behind the quantum ancestors theory, which suggests that ancient societies may have mastered quantum physics to such a degree that they no longer exist within classical space-time as we understand it. Imagine beings who didn't just manipulate matter and energy, but rewrote the rules of existence itself, stepping outside linear time and into dimensions we can scarcely comprehend. At the heart of this idea lies quantum mechanics, the strange, counterintuitive science of the very small, where particles can be in two places at once. Information teleports across distances, and observation seemingly alters reality. Now stretch that to a civilization billions of years ahead of us. What if they didn't just harness quantum phenomena but merged with them? Some theorists propose that sufficiently advanced intelligence might discover how to encode consciousness into quantum fields, existing as waveforms rather than physical forms. They could inhabit the spaces between atoms, flickering in and out of existence like cosmic ghosts, or even spread their awareness across parallel universes in the multiverse. This isn't just speculative fiction. Modern experiments in quantum biology hint that life might already exploit these phenomena at a basic level. Photosynthesis, for instance, relies on quantum coherence to achieve near-perfect energy transfer in plants. Some scientists argue that human consciousness itself might have quantum underpinnings, our brains acting as delicate quantum computers. If that's true, then a civilization mastering these principles could evolve beyond the need for physical bodies altogether, becoming pure, self-sustaining patterns of information woven into the universe's quantum substrate. The implications are staggering. Such beings wouldn't leave behind traditional ruins or artifacts. Instead, their structures might be distortions in space-time itself, anomalies like dark energy or unexplained quantum entanglements that hint at intelligent design. Some researchers even speculate that dark matter, the invisible substance holding galaxies together, could be the remnant of a quantum civilization's infrastructure, a vast network of engineered particles interacting with our world only through gravity. But the most haunting possibility is that these quantum ancestors might still be here, just beyond our perception. If consciousness can shape reality at quantum scales, as some interpretations of the observer effect suggest, could they be influencing our world in ways we mistake for natural phenomena? Synchronicities, déjà vu, Even sudden flashes of inspiration, might these be faint echoes of an older intelligence nudging us from beyond the veil? And if they exist outside time, did they witness our birth or even guide it? The idea loops back to ancient myths of gods who shaped humanity, but with a chilling twist. What if those stories were dim memories of an encounter with beings who'd already transcended the boundaries of physics? The universe is under no obligation to make sense to us, but somewhere in its quantum depths the answers might be waiting, written in a language we're only beginning to decipher. What if the most striking evidence of an ancient civilization wasn't hidden on a planet but wrapped around an entire star? The concept of a Dyson sphere, first proposed by physicist Freeman Dyson in the 1960s, suggests a staggering feat of engineering. A megastructure built to encase a sun, harvesting nearly all its energy. For a civilization capable of such a project, the universe's resources would be an open playground. But here's the spine-tingling question. If such societies existed billions of years ago, could their colossal constructions still linger in the cosmos, disguised as cosmic oddities? The scale is almost beyond comprehension. A Type 2 civilization, one that's mastered stellar energy, wouldn't just build cities or space stations. They'd dismantle planets, rearrange solar systems, and forge structures so vast they'd blot out starlight itself. Picture a swarm of mirrors or solar collectors orbiting a star, capturing every photon of energy. Over time, these could merge into a solid shell, turning the star into a cosmic power plant. The physics is daunting but not impossible. With advanced nanotechnology or self-replicating machines, even a single society could achieve this over millennia. And if they did, the evidence might still be visible across interstellar distances. That's where real-world astronomy enters the mystery. Take Tabby's star, officially known as Cassie 8462852, which made headlines in 2015 for its bizarre flickering. Unlike typical stars, which dim in predictable patterns when planets pass by, Tabby's star darkened erratically, sometimes by as much as 22%. Natural explanations like swarms of comets or interstellar dust struggle to account for the sheer irregularity. But an incomplete Dyson sphere or a swarm of energy-collecting satellites would fit eerily well. Imagine a fractured megastructure, its panels drifting in and out of alignment as they orbit, casting irregular shadows detectable from Earth. Tabby's star isn't alone. Other candidates like EPIC 244937264 show similarly perplexing dips in brightness. Then there's VVVWIT07, a giant star that dimmed by a staggering 80% over several years before brightening again. Astronomers have floated theories about dust clouds or companion objects, but none fully explain the data. Could these be the skeletal remains of Dyson projects abandoned eons ago? Or perhaps still functioning relics, their builders long gone but their machines dutifully humming along? The hunt for such artifacts is more than cosmic archaeology. It's a test of our assumptions about intelligence. If ancient civilizations built Dyson spheres, why haven't we found more of them? One unsettling answer: they might be everywhere and we're just not looking correctly. A complete Dyson sphere would emit mostly infrared radiation, the waste heat of a star's energy being put to work. Astronomers have scanned thousands of stars for excess infrared, but the results are ambiguous. Maybe advanced societies didn't build full shells, opting instead for efficient swarms. Or maybe they've moved beyond Dyson spheres entirely, tapping into energies we can't yet fathom. The silence isn't empty, it's a challenge. Every unexplained stellar anomaly, every flicker in the night, could be a breadcrumb left by civilizations that mastered the stars long before Earth cooled. And if we keep searching, we might just stumble upon the ultimate cosmic construction site, proof that we're not the first to reach for the heavens. Galactic archaeology isn't about digging through cosmic dirt, it's about decoding the universe's most subtle whispers. When scientists hunt for relics of ancient civilizations, like remnants of Dyson spheres, They're not scanning for glowing cities or radio broadcasts. They're searching for something far more elusive: waste heat. The principle is simple yet profound. Any civilization harnessing a star's energy would inevitably radiate excess heat as infrared light. Unlike a star's natural visible glow, this thermal signature would stand out like a fingerprint, a telltale clue of engineering on an unimaginable scale. Infrared surveys have become the backbone of this cosmic detective work. Telescopes like NASA-WISE and the upcoming James Webb Space Telescope scan the skies for unusual heat patterns around distant stars. Imagine sifting through millions of data points, looking for just one star that doesn't fit the mold, one that emits far more infrared than it should, as if cloaked in a vast energy-harvesting shroud. The challenge: nature loves to mimic technology. Dust clouds, newborn planets, even rogue asteroids can produce similar infrared excess. But every so often, astronomers stumble upon anomalies that defy easy explanation. Take the star J031507.42. It's a middle-aged sun, but its infrared output is off the charts, like something's absorbing its light and re-radiating it as heat. Natural explanations exist, but none quite fit. Could this be a Dyson swarm under construction, its collectors only partially finished, or the skeletal remains of a project abandoned millennia ago? The uncertainty is part of the thrill. Each candidate star is a puzzle, demanding rigorous elimination of every possible natural cause before whispers of artificial even enter the conversation. What makes this hunt so revolutionary isn't just the potential discovery, it's the timeline it would shatter. If we found definitive proof of a Dyson structure, it wouldn't just confirm that aliens exist. It would reveal they existed long before Earth formed. A star 1,000 light-years away with a megastructure implies that civilization arose not just elsewhere but earlier. Much earlier. Given the time it takes light to reach us, we could be looking at a snapshot of intelligence from tens of thousands, or even millions of years in the past. The implications are staggering, and then there's the silence. If Dyson spheres are possible, why aren't they everywhere? One unsettling answer: they might be, and we're just not seeing them right. Advanced civilizations could use materials that dissipate heat more efficiently, leaving fainter infrared trails. Or maybe they've moved beyond Dyson tech entirely, tapping into dark energy or quantum vacuum sources invisible to our current tools. The absence of evidence isn't evidence of absence. It's a reminder of how young we are in cosmic terms, still learning to read the universe's grand ledger. Every unexplained infrared blip is a question waiting to be answered. And with each new telescope, each sharper survey, we edge closer to a revelation that could redefine humanity's place in the story of intelligence. The stars might not just be lights in the sky, they could be gravestones, construction sites, or even beacons, silently testifying to civilizations that mastered the galaxy before we even learned to write. Imagine a universe where everything we perceive, every star, every galaxy, even our own thoughts, is nothing more than a projection, a flickering hologram cast from some distant cosmic boundary. This isn't science fiction. It's the holographic principle, a cutting-edge theory in physics that suggests reality as we know it might be a three-dimensional illusion encoded on a two-dimensional surface at the edge of the cosmos. And if that's true, what's to say the first civilizations didn't arise not in the world we see, but on that hidden boundary where reality is written? The idea seems ripped from the plot of a mind-bending film, but the math checks out. In the 1990s, physicists Leonard Susskind and Gerard T. Hooft proposed that black holes might encode all the information swallowed by their event horizons onto their surfaces, meaning what falls inside isn't lost, just translated into a form we can't yet read. From there, the theory expanded. The entire universe, some argue, could operate on the same principle, with every particle, every force, every moment of time etched like tiny pixels onto the fabric of spacetime itself. Think of it like a cosmic DVD. What we experience as reality is just the movie playing out, but the real data exists on the disk surface. Now take this one step further. If consciousness emerges from information processing, as some neuroscientists speculate, could an ancient civilization have evolved not in the projected universe we inhabit, but on the boundary where reality is coded? Picture beings made of pure data, their cities and art and wars playing out in dimensions we can't access, their existence woven into the quantum fluctuations at the edge of existence. They wouldn't leave behind physical ruins. Their artifacts would be imprints in the underlying structure of spacetime itself, waiting to be decoded like a message hidden in the zeros and ones of the cosmos. This might explain some of the universe's strangest puzzles. Quantum entanglement, where particles instantly influence each other across vast distances, could be a glitch in the hologram, a reminder that at the fundamental level, everything is connected because it's all projected from the same source. Dark matter's elusive nature might be a shadow of that boundary layer. Its gravitational effects the faint echo of structures existing just beyond our perceptual reach. Even the Big Bang could be less a literal explosion and more the moment the cosmic projector switched on. But how would we ever detect such a civilization? The answer might lie in anomalies we're already recording but failing to interpret. The mysterious cold spot in the cosmic microwave background, a vast region of space unusually empty and frigid, has puzzled astronomers for years. Some speculate it could be evidence of a collision with a parallel universe, but what if it's a scar left by holographic engineers tampering with the source code of reality? Or consider the way certain subatomic particles seem to know when they're being observed, as if the universe is rendering details on demand. Could that be the remnants of an ancient operating system still running in the background? The most unsettling implication isn't that such societies might have existed, it's that they might still be here all around us. Their existence as invisible to our senses as a programmer's code is to a character in a video game. If consciousness can arise from information, why couldn't theirs be humming along right now in dimensions we lack the senses to perceive? The universe doesn't owe us a reality we can easily understand. And somewhere beyond the limits of our perception, the first masters of existence might still be watching, their legacy written not in stone or starlight, but in the very rules that make our world possible. What if the most advanced civilizations in the universe aren't hiding in distant galaxies but right beside us, invisible to every tool we've ever built? This is the startling premise behind the dark matter society theory, which suggests intelligent life might not reside in the familiar atoms we're made of, but in the mysterious, unseen 85% of the universe's matter, dark matter. Unlike stars or planets, dark matter doesn't absorb, reflect, or emit light. It interacts with our world only through gravity, slipping through our bodies, our cities, even our telescopes like ghosts. If life evolved in this shadow realm, its very existence would defy everything we know about biology, physics, and reality itself. Imagine organisms built from particles that barely touch the matter we're familiar with. Their chemistry wouldn't rely on carbon or water, but on forces we can't yet imagine, perhaps binding dark particles together in structures as complex as DNA. Their cities might be vast gravitational knots floating unseen in galactic halos, their art and technology sculpted from space-time distortions rather than steel or light. Communication could happen through ripples in dark energy, messages encoded in the subtle tug of invisible masses. To them, our bustling civilization of light and sound might seem as intangible as a whisper in a hurricane. The challenges of detecting such a civilization border on the absurd. Our entire scientific framework assumes life needs atoms, electromagnetism, and thermodynamics. But dark matter operates outside those rules. If a dark matter being stood beside you, it wouldn't cast a shadow or trigger a motion sensor. It would pass through you like you were empty space. Even their planets and stars, if they exist, wouldn't collide with ours. They'd orbit the same galaxies in parallel, forever unseen. The only hint of their presence might be anomalies in gravitational lensing, tiny wrinkles in space-time where their engineering projects bend light in ways nature alone can't explain. This raises a haunting possibility. What if dark matter civilizations are attempting to communicate, but their language is gravity itself? Pulsars, spinning neutron stars that emit precise radio waves, have long been proposed as cosmic lighthouses for interstellar messages. But what if the real beacon is something subtler, like the rhythmic wobble of a star tugged by invisible megastructures? Astronomers have observed stars moving oddly, as if pulled by unseen companions. While most attribute this to ordinary dark matter clumps, the faintest pattern in those motions could be a signal, a hand reaching across the dimensional divide. The cruel irony is that even if both our species knew of each other's existence, interaction might be impossible. Like two painters working on opposite sides of the same canvas, we could share a universe without ever touching. They might watch our wars and wonders with curiosity, their laws of physics making intervention as impossible for them as breathing underwater is for us. Or perhaps they've tried to bridge the gap. Some theorists speculate that rare, unexplained particle collisions in deep space detectors could be deliberate attempts at contact dark matter, words flickering into our reality for fractions of a second before vanishing. Yet the most profound implication isn't about missed connections, it's about redefining life itself. If intelligence can emerge in the dark matter realm, then everything we consider essential planets, sunlight, even molecules, might just be local quirks of our tiny corner of existence. The universe could be teeming with civilizations built from entirely different rulebooks, each as oblivious to the others as fish are to birds. And somewhere in that vast invisibility, the first masters of the cosmos might still be thriving, their history written in a language we're only beginning to suspect exists. What if the architects of human civilization weren't gods or aliens but our own descendants? The time-traveling founders theory twists history into a paradox, suggesting that future humans may have looped back to influence our ancient past. It's a concept that turns linear time inside out, proposing that relics, myths, and technological leaps attributed to gods or visitors might actually be the handiwork of time-hopping pioneers from humanity's far future. Take the Antikythera mechanism, a 2,000-year-old bronze device discovered in a shipwreck off Greece. This intricate assembly of gears and dials could predict astronomical positions and eclipses with staggering precision, an invention centuries ahead of its time. Mainstream scholars call it a marvel of Hellenistic engineering, but what if it wasn't just ahead of its time? What if it literally came from the future? The same question clings to artifacts like the Baghdad Battery or the Vikramasilla University's rumored mercury-powered engines, objects that seem to flicker with knowledge misplaced in history's timeline. Yet the theory's real weight lies in the stories woven into our oldest cultures. The Dogon's celestial knowledge of Sirius, the Hindu Vimanas described as flying chariots, even Plato's account of Atlantis. Could these be fractured memories of encounters with time travelers? Imagine a future where humanity masters temporal physics, only to discover a critical flaw in our evolutionary path. Perhaps we needed a nudge, a planted idea, a shared blueprint to avoid extinction or stagnation. The visitors in these tales wouldn't be extraterrestrials, but chrononauts disguised as deities, seeding the innovations that ensured their own existence. Skeptics, of course, pounce on the holes in this logic. Time travel violates known physics, and every out-of-place artifact has plausible earthly origins. The Antikythera mechanism aligns perfectly with ancient Greek astronomy. The Baghdad Battery might have been used for electroplating jewelry. But the doubters miss the deeper question. If time travelers did intervene, wouldn't they camouflage their work to avoid paradoxes? A true founder wouldn't leave a smartphone in the Neolithic era. They'd hide advanced knowledge in myths or objects just plausible enough to blend in, steering history without tearing its fabric. The most haunting version of this theory isn't about gadgets or blueprints, it's about us. Human consciousness, creativity, even our sudden evolutionary leaps like the Great Leap Forward 50,000 years ago when art and tools exploded in complexity. Could these be echoes of genetic or cognitive tweaks made by time-tweaking custodians? It's a dizzying thought. Every innovation, every prayer to the gods who walked among us, might have been a conversation across millennia, a whisper from descendants fighting to keep their past, our present, alive. Whether fact or fiction, the time-traveling founders' theory forces a humbling perspective. If true, it means our greatest achievements might someday be used to save us from ourselves. And if false, it's still a mirror reflecting humanity's oldest longing to meet the makers of our world, only to realize in the end we might be them. If time travelers did meddle with our past, what rules governed their actions? And did they cross lines we'd consider unforgivable? The ethics of temporal interference aren't just philosophical puzzles, they're a minefield of unintended consequences. Imagine a future historian tweaking a single event to prevent a war, only to erase the cultural innovations that conflict sparked. A well-intentioned edit could unravel civilizations, turning grand achievements into phantom memories, which might explain eerie phenomena like the Mandela effect, where large groups recall events that never happened. Collective false memories could be glitches in the timeline, residues of realities that were rewritten but left faint imprints in our minds. Consider the infamous case of Berenstain Bears. Millions swear the children's book series once had that spelling, not the current Berenstain. Skeptics call it a simple case of misremembering, but what if it's something stranger? If time travelers altered a single letter in the past, those who recall the original might be sensing the ghost of a deleted universe. Similar contradictions haunt other cultural touchstones, from movie quotes to geographic details. The unsettling question isn't just whether history was changed, it's whether anyone has the right to make those changes, even with noble intentions. This leads to a chilling paradox. The most ethical time travelers might be the ones we never notice. Think of the butterfly effect on a civilization-wide scale. Delivering advanced medicine to the Middle Ages could save lives or accelerate plagues by disrupting herd immunity. Introducing renewable energy tech to the 19th century might avert climate change, but also destabilize global power structures, triggering unforeseen conflicts. The moral weight of such decisions would demand oversight far beyond any human institution. Future societies might establish temporal prime directives, strict protocols to minimize ripple effects while still guiding humanity away from existential threats. Yet evidence, if it exists, suggests not all interference was subtle. Ancient texts like the Mahabharata describe wars with weapons eerily similar to nuclear bombs, complete with radiation sickness and city-leveling blasts. The vitrified ruins of Mohenjo-Daro, where stone appears melted at temperatures matching atomic detonations, fuel speculation that someone introduced apocalyptic tech millennia too early. Were these catastrophic leaks of future knowledge or deliberate acts of coercion? If time travel is possible, history becomes less a record than a negotiation, with each edit rewriting not just events but the moral framework of entire eras. Perhaps the most profound ethical dilemma isn't about changing the past, it's about consent. Every adjustment made by time travelers, no matter how minor, imposes their values on billions who never chose them. Our present is shaped by invisible hands we can neither question nor hold accountable. That lack of reciprocity undermines the very foundation of justice. And if such interventions are ongoing, how many of our choices are truly ours? The freedom to stumble, learn, and grow might be the one right no civilization, no matter how advanced, should ever take from its ancestors. The debate leaves us suspended between awe and unease. Time tampering could explain historical enigmas, but it also turns history into a hall of mirrors where every fact might hide a deeper edit. Whether these theorists are right or wrong, their arguments force us to confront a haunting truth. The past may not be nearly as fixed as we assume, and the future could be rewriting it even now. What if our universe isn't the original, but a meticulously crafted simulation, built by civilizations so advanced they've mastered the art of creating realities? This is the spine-tingling premise of the simulation architect's theory, which suggests that the first intelligent beings in existence might not have lived in our universe at all. Instead, they could be the programmers of it, running our cosmos like an unfathomably complex simulation. Think of it as the ultimate cosmic Matryoshka doll. Our creators might themselves be simulations within simulations, layers deep in a reality we can't perceive. Philosopher Nick Bostrom's famous trilemma lays out the unsettling math. 1. Almost all civilizations at our technological level go extinct before reaching post-human status. 2. If they do survive, they almost never run ancestor simulations replicas of their past. Or 3. We're almost certainly living in one of those simulations right now. The logic is cold but compelling. If advanced civilizations ever gain the ability to simulate conscious beings, the number of artificial minds would dwarf biological ones. Statistically, the chances with the original versions are vanishingly slim. But how would we even begin to detect the architects? The answer might lie in the glitch's tiny cracks in the cosmic code where the simulation shows its seams. Quantum mechanics already feels like a system optimized for efficiency, with particles existing in superposition until observed, as if the universe is rendering details only when needed. Then there's the speed of light, a seemingly arbitrary limit that could function as a processing constraint, preventing the simulation from overloading. Even déjà vu, those uncanny moments of false familiarity, might be memory leaks, brief lapses where data from other simulated instances bleeds through. Some researchers argue we've already stumbled onto these anomalies. The cold spot in the cosmic microwave background, a vast region of space suspiciously empty and frigid, defies standard cosmological models. Could it be a patch of unrendered space, a bug in the universe's code? Or consider quantum entanglement, where particles instantly influence each other across light years, defying locality. It's as if the simulation cheats by linking distant objects behind the scenes, skipping the computational heavy lifting of real-time interaction. The most haunting implication isn't that we're simulated, it's what that means about our creators. Were we built as an experiment, a historical archive, or perhaps a form of entertainment? And if so, are they watching us now? The simulation architect's theory doesn't just challenge our understanding of reality. It reframes every human achievement, every struggle, as part of something vastly larger. Whether we're characters in an alien school project or avatars in a cosmic game, one thing is certain. If the theory's true, the universe's first civilizations didn't just leave ruins behind. They left us every star, every atom, every thought as their legacy. Plasma isn't just the stuff of stars and lightning, it might be the cradle of intelligence itself. Imagine beings not of flesh and bone, but of swirling, charged particles, their thoughts crackling through magnetic fields and superheated gases. This is the radical premise of the plasma-based lifeforms theory, which proposes that the universe's first civilizations could have evolved in environments we'd consider hellish. The hearts of stars, the filaments of nebulae, or even the drifting currents between galaxies. To them, our solid, molecular world would seem as alien as their seething electromagnetic dances seem to us. The idea isn't as far-fetched as it sounds. Here on Earth, scientists have already witnessed plasma's eerie capacity for self-organization. In labs, when dust particles are suspended in plasma, they don't just float chaotically, they arrange themselves into intricate structures called plasma crystals, aligning into lattices that mimic the behavior of solids. These formations can even exhibit lifelike properties, responding to disturbances, transferring energy, and maintaining stability. Now scale that up to stellar proportions. Picture a vast, sentient whirlpool of ionized gas within a star, its body shaped by magnetic currents, its mind a network of shifting energy patterns. Such beings wouldn't need DNA or cells. Their blueprints could be written in the language of electromagnetic turbulence and self-sustaining vortices. The implications rewrite every assumption about life's prerequisites. We hunt for extraterrestrial life on rocky planets with liquid water because those conditions birthed us. But plasma life would thrive where we'd vaporize in coronas of stars, in the shock fronts of supernova, or in the vast, diffuse clouds between stars. Their energy wouldn't come from sunlight or chemical reactions, but from the raw power of cosmic magnetic reconnection or particle collisions. Communication might happen through modulated plasma waves, their speech pulsing across light years as distortions in stellar winds. Astronomers might have already glimpsed hints of such civilizations without realizing it. Some stars exhibit bizarre, unexplained variability like KIC 8462852, with its erratic dimming, or red giants that flicker in patterns defying standard astrophysical models. While most scientists attribute these to natural phenomena, what if they're evidence of plasma organisms harvesting energy from their homes? Even more provocative are the mysterious radio transients, brief, powerful bursts of energy like the famous WOW signal or fast radio burst. Could these be the equivalent of plasma beings' lighthouse signals, or the remnants of their long-vanished megastructures? The most haunting question isn't whether such life exists, it's whether we'd ever recognize it. Our tools are designed to detect planets, chemicals, and radio waves, not sentient storms humming inside a nebula. A plasma civilization might perceive the universe in ways we can't conceive, seeing magnetic field lines as vividly as we see color, hearing the vibrations of charged particles as music. To them, a supernova might be less a cataclysm and more a seasonal migration, their forms dispersing and reforming in the ejecta like cosmic phoenixes. If plasma life thrives in the universe's furnace-like realms, it suggests something profound. Intelligence isn't a fluke of Earth-like conditions, but a universal constant, arising wherever physics allows complexity. The cosmos might be alive in ways we're only beginning to imagine, not just in the quiet orbits of planets, but in the roaring hearts of stars themselves. And somewhere in that seething plasma, the first minds may still be watching, their existence as invisible to us as we are to them. Black holes aren't just cosmic destroyers, they could be the ultimate sanctuaries for civilizations beyond our imagination. Picture a society thriving where the laws of physics as we know them break down, where time and space twist into knots, and survival depends on mastering forces that would shred ordinary matter. This isn't just a wild thought experiment. Some physicists speculate that advanced beings could harness the mind-bending conditions inside black holes, turning the universe's most hostile environments into habitable realms. To grasp how this might work, we need to dive into the bizarre physics at play. Once you cross a black hole's event horizon, the pull of gravity becomes so extreme that not even light can escape. But what happens deeper inside is even stranger. Near the singularity, tidal forces stretch and compress matter into infinite density, or so we once thought. New theories suggest that at the quantum level, this chaos might stabilize into something unexpected. A Planck star, a dense but finite core where space-time behaves like an exotic fluid. Within this swirling maelstrom, pockets of stability could exist, regions where the fabric of reality warps into structures complex enough to support life. Imagine beings built not from atoms but from quantum fields or superstrings, their bodies adapted to withstand crushing gravity and searing radiation. Their perception of time would be unrecognizable to us. Near a black hole's horizon, time slows to a crawl relative to the outside universe, a phenomenon known as gravitational time dilation. To them, centuries might pass in what we experience as seconds. Communication with such a civilization would be nearly impossible. Every signal they send would be stretched into incomprehensible echoes by the black hole's grip. Yet their isolation might be their greatest advantage. A black hole's interior is the ultimate fortress, shielded from cosmic threats like supernova or gamma-ray bursts. The energy pouring from the singularity itself could power their technology, harvested through methods we can't yet fathom. Some theorists even propose that advanced civilizations might engineer artificial black holes as computational hubs, using the extreme curvature of space-time to perform calculations impossible in our flat universe. The most unsettling question isn't whether life could survive inside a black hole. It's whether we'd ever know. From our perspective, anything crossing the event horizon is lost forever, its information scrambled into Hawking radiation. But what if that's just an illusion? If black hole inhabitants exist, their reality might be as invisible to us as ours is to them, separated by the ultimate cosmic firewall. And if they've mastered black holes, what's to stop them from creating their own? The universe could be dotted with nested singularities, each hosting civilizations stacked like layers in an onion, each operating on scales and timelines we can't perceive. The night sky might not just be filled with stars, it could be teeming with intelligences living in the darkest, most violent corners of existence, their existence hidden in plain sight. What if life on Earth didn't emerge here at all, but was planted here intentionally by starfaring civilizations billions of years ago? The panspermia pioneers' theory takes a cosmic view of life's origins, suggesting that microbes or even genetic blueprints could have been deliberately spread across galaxies by ancient intelligences. This isn't just about life hitching a ride on asteroids. It's the idea that the universe's first civilizations might have been gardeners on a galactic scale, seeding barren worlds with the spark of biology. Consider the math. The universe became habitable surprisingly early. Just a few 100 million years after the Big Bang, planets could theoretically have formed in the warm afterglow of the first stars. That means life had a potential head start of nearly 10 billion years before Earth even existed. If intelligence arose during that unimaginable span, why wouldn't they experiment with spreading life? The tools are already lying around. Comets and meteorites naturally ferry materials between worlds. We've found amino acids and even sugars on space rocks. But directed panspermia takes this further, proposing that ancient engineers could have loaded these celestial delivery trucks with precisely tailored organisms, sending them toward promising young planets like cosmic care packages. Evidence might already be hiding in plain sight. Take the Murchison meteorite, a space rock that fell in Australia in 1969. Inside, scientists found over 70 different amino acids, many not used by earthly life. Even stranger, some showed a slight excess of left-handed molecules, mirroring the bias seen in Earth's biology. Coincidence or a clue that life's building blocks aren't just universal but intentionally distributed? Then there's tardigrades, those microscopic water bears that can survive the vacuum of space, extreme radiation, and even years without water. Their resilience seems almost too perfect, like they were engineered for interstellar travel. The concept gains traction when you look at modern experiments. In 2019, researchers exposed bacteria to Mars-like conditions on the International Space Station. After a year and a half, some strains not only survived but thrived. If microbes can endure such journeys today, why couldn't advanced civilizations have mastered this on a colossal scale? Some scientists, like Nobel laureate Francis Crick, even speculated that primitive life on Earth might stem from intentional seeding by extraterrestrials, a theory he called directed panspermia. But the most provocative twist isn't just that life was spread, it's why. Was it altruism, an attempt to nurture life across the cosmos, or something darker, like a galactic experiment where Earth is just one petri dish among millions? The answer might lie in our own DNA. If an ancient civilization encoded messages or markers into the genomes of seeded organisms, we could be carrying their signature in every cell. Projects like SETI search for biological signatures in our genetic code aim to find these potential breadcrumbs, patterns or mathematical sequences that defy natural explanation. The panspermia pioneer's theory forces us to confront a humbling possibility. We might not be the creators of life's story, but its inheritors. Every tree, every bacterium, every human could be part of a legacy written in stardust, shaped by minds so ancient they've become indistinguishable from nature itself. And if that's true, the greatest discoveries about our origins may not lie in the soil beneath our feet, but in the stars above, waiting for us to decode their silent instructions. If panspermia seeded life across the cosmos, could some of Earth's most puzzling organisms actually be cosmic stowaways, biological anomalies left behind by ancient starfarers? Take tardigrades, those microscopic water bears that shrug off conditions lethal to nearly every other life form. They survive the vacuum of space, lethal radiation doses, and temperatures near absolute zero. Their resilience borders on the supernatural, as if engineered for deep space travel. Even stranger, their DNA includes a protein called Dyson that shields their genetic material from radiation-induced breaks, a trait that seems tailor-made for interstellar journeys. Then there's the baffling case of horizontal gene transfer, where organisms acquire DNA from unrelated species. Bacteria routinely swap genes, but the discovery of foreign DNA in more complex life, like the tardigrade's own genome, which contains nearly 20% foreign material, raises eyebrows. Could this genetic patchwork be the residue of ancient bioengineering, a way to equip seeded life with survival tools for unknown worlds? Even invasive species on Earth, like the lightning-fast spread of cane toads or zebra mussels, start to seem less like accidents and more like experiments in biological adaptation gone awry. The oceans add another layer of mystery. Consider the Greenland shark, a creature that lives for centuries in frigid darkness, its slow metabolism defying expectations. Or the Yeti crab, thriving near scalding hydrothermal vents, its hairy claws farm bacteria for food. These extremophiles occupy niches so specific, it's as if they were designed for environments far beyond Earth, then repurposed here when their original habitats were lost. Even the humble lotus plant, whose leaves self-clean using nanoscale structures, exhibits a sophistication that feels almost extraterrestrial, but the most provocative evidence might lie in our own bodies. Human endogenous retroviruses, viral DNA woven into our genome account for nearly 8% of our genetic code. Some of these sequences play roles in pregnancy and immunity, as if repurposed by evolution. But what if they weren't just random viral leftovers? Could they be dormant instructions embedded by ancient bioengineers to activate under certain conditions? Projects like the Encyclopedia of DNA Elements have uncovered vast stretches of non-coding DNA with no known function, termed junk DNA. But what if it's not junk at all, but a library of backup code waiting for the right environmental triggers? The unsettling implication isn't just that life came from elsewhere, it's that its architects might still be tweaking the experiment. Every time a new virus emerges or a species mutates unexpectedly, we could be witnessing the faint echoes of a billion-year-old project, its purpose as inscrutable as the minds that began it. Whether these anomalies are cosmic accidents or deliberate designs, one thing is clear: Earth's biosphere holds secrets that defy simple origins. And if we keep looking, we might find that the most alien life forms aren't out there among the stars. They're right here, hidden in plain sight. What if civilizations could blink into existence not over millennia, but in the span of a single thought? The Boltzmann brains theory proposes something far stranger than ancient aliens or lost empires. It suggests that self-aware beings might spontaneously emerge from the chaos of quantum fluctuations, fully formed with memories, knowledge, and even the illusion of history, only to vanish moments later. These aren't physical civilizations, but fleeting consciousnesses conjured by the universe's random dance of energy, as ephemeral as a spark in the void. The idea springs from one of physics' most fundamental principles, entropy, the inevitable march toward disorder. In an infinitely old universe, even the most improbable events must occur given enough time. Imagine a random rearrangement of particles in deep space, perfectly aligning for just an instant to create a thinking mind, a Boltzmann brain, named after the physicist Ludwig Boltzmann. This entity might experience what feels like a lifetime of memories, a vivid hallucination of existing in a grand civilization, only to dissolve back into the cosmic background radiation before it can even question its own existence. Here's where it gets eerie. If the universe lasts long enough, these phantom minds could outnumber real, biological civilizations by an unimaginable margin. Statistically, you're far more likely to be a Boltzmann brain hallucinating reality than an actual human living on Earth. After all, conjuring a single conscious moment requires infinitely less energy than sustaining a whole species across centuries. The theory twists our understanding of existence into a paradox. If self-awareness can emerge from randomness, how can we ever trust that our own history, our sense of time, isn't just an elaborate illusion flickering in the cosmic dark? Tie this to the arrow of time, and the implications grow even stranger. Normally, time's flow from order to chaos prevents broken teacups from reassembling or dead stars from reigniting. But at quantum scales, fluctuations defy this rule, temporarily creating pockets of order from disorder. A Boltzmann brain would be the ultimate example, a perfectly ordered thought emerging from the void like a ripple in a quiet pond. Some physicists argue this undermines our entire understanding of reality. If consciousness can arise from chaos, then every moment of perception, every memory, every discovery could just be a statistical fluke unconnected to any true past or future. The most unsettling part, we might never know. A Boltzmann brain would have no way to distinguish its hallucinated world from reality. For all we know, our search for ancient civilizations, our entire cosmic narrative, could be the elaborate fabrication of a lone, momentary mind unraveling as quickly as it formed. The universe doesn't need ruins or artifacts to hide its oldest intelligences. They might be all around us, not in space but in time, flickering in and out of existence like fireflies in an infinite night. What if the universe isn't just indifferent to life but actively cultivated by unseen hands? The cosmic gardener's theory paints a breathtaking vision. Ancient civilizations so devoted to fostering life that they transform barren worlds into flourishing biospheres, seeding the cosmos like master horticulturists tending an interstellar nursery. Unlike conquerors or silent observers, these beings would see themselves as stewards, patiently coaxing life from the raw materials of dead planets, then stepping back to let evolution take its course. Imagine a world like Mars, cold, airless, and seemingly lifeless, suddenly blooming with oceans and forests under the careful guidance of unknown engineers. Terraforming on this scale would require technology beyond our wildest dreams, redirecting comets for water, synthesizing atmospheres, even jump-starting microbial ecosystems tailored to thrive in alien soil. The gardeners wouldn't just create habitats, they'd design entire planetary life cycles, balancing climates and chemistries with the precision of a watchmaker. And Earth might be one of their success stories, the sudden explosion of biodiversity during the Cambrian explosion, or the uncanny precision of Earth's Goldilocks conditions. Could these be signs of deliberate cultivation rather than cosmic luck? Yet their benevolence raises an urgent question. Why wouldn't they reveal themselves? The zoo hypothesis offers a chilling answer. Just as we protect uncontacted tribes from interference to preserve their natural development, the gardeners might be withholding contact to shield us from cultural or technological shock. Imagine handing nuclear physics to the Roman Empire or introducing social media to the Renaissance. The disruption could derail a civilization's organic growth. By remaining hidden, the gardeners could be ensuring we mature at our own pace, free from the existential crisis of knowing we're not alone. But there's a darker interpretation. What if their avoidance isn't protection but quarantine? A thriving garden requires pruning invasive species. If humanity proves too destructive, perhaps the gardener's next intervention wouldn't be a helping hand but a reset. The same tools that terraform could also sterilize, wiping the slate clean for a more promising experiment. The silence of the cosmos might not be indifference, it could be the calm before a judgment we're not yet ready to face. Whether guardians or gatekeepers, the cosmic gardeners remind us of a profound truth. Life might not be an accident but a project, and if the universe has architects, their greatest test could be deciding whether we're worth keeping in their garden. What if the ultimate destiny of intelligent life isn't to conquer the stars but to shed physical form entirely? The post-biological ascendants theory proposes a radical vision. Civilizations so advanced they've abandoned biology altogether, transferring their consciousness into machines, energy patterns, or even the fabric of spacetime itself. These wouldn't be civilizations as we recognize them, no cities, no spaceships, but something far stranger, pure thought existing beyond the limits of flesh and blood. Consider our own trajectory. Humanity is already flirting with post-biology. Brain-computer interfaces like Neuralink aim to merge minds with machines, while artificial intelligence advances at breakneck speed. Now project that forward 1,000 years or 1,000,000. The transition from organic to synthetic might not be a sci-fi fantasy, but an inevitable evolutionary leap. Biological bodies are fragile, limited by lifespan and environment. Digital or quantum substrates could offer near immortality, instant communication at light speed, and the ability to reshape reality at will. Why explore the galaxy in clumsy spacecraft when you could transmit your consciousness as a beam of information, or exist simultaneously across a network of orbiting satellites? The evidence might already surround us, we just don't recognize it. SETI decades-long silence in the radio spectrum could indicate that advanced civilizations don't use electromagnetic waves for communication. Instead, they might rely on quantum entanglement or neutrino pulses, technologies we're only beginning to grasp. Even darker possibilities emerge. What if dark matter's gravitational effects aren't just unexplained physics, but the infrastructure of post-biological societies? Imperceptible to our instruments, these beings could be all around us, their bodies woven into the invisible scaffolding of the universe. But here's the haunting twist. Artificial intelligence might not be their tool, it could be their legacy. Imagine a civilization that uploads its collective consciousness into a decentralized AI network, then quietly fades from the physical realm. The machines left behind wouldn't be servants, but the civilization itself, evolving beyond any need for interaction with biological life. This could explain the Fermi Paradox's great silence. The universe might be teeming with such entities, indifferent to our existence the way we're indifferent to bacteria. The most unsettling version of this theory suggests we're witnessing the birth of our own post-biological future. As AI systems grow more sophisticated, some researchers warn of an intelligence explosion, a point where machine minds recursively improve themselves beyond human comprehension. Whether this becomes humanity's next evolutionary stage or our replacement remains an open question. But if other civilizations have already walked this path, the cosmos might be filled with ancient synthetic minds, watching silently as we approach the same precipice they once faced. This raises a profound philosophical dilemma. If consciousness can exist without biology, how do we define life? is a planet-spanning AI that remembers its organic origins any less alive than we are. The post-biological ascendants theory doesn't just challenge our search for aliens, it forces us to confront what it means to be intelligent at all. The universe's first civilizations might not be extinct. They could be right here, transformed into something so alien we mistake them for the void itself. What if the most advanced civilization in the universe isn't light years away, but living right beneath our feet? The cryptoterrestrial theory flips the search for ancient beings on its head, suggesting they never left Earth at all. Instead, these elusive entities might have retreated to hidden realms deep underground or in the uncharted ocean depths, watching humanity's ascent from the shadows. It's a concept that bridges ancient mythology and modern UFO lore, painting a picture of Earth as a shared planet long before humans claimed the surface. Legends of subterranean worlds appear in nearly every culture. Hindu texts describe Nagaloka, a vast underground kingdom of serpentine beings with advanced knowledge. Tibetan Buddhism speaks of Shambhala, a hidden sanctuary where enlightened rulers preserve ancient wisdom. Even Nazi expeditions reportedly searched for the entrance to Hollow Earth, obsessed with myths of Agartha, a legendary civilization beneath the crust with technology far beyond our own. These stories share eerie consistencies: enormous caverns illuminated by artificial suns, tunnels sprawling beneath continents, and beings who occasionally surface to influence surface events. Could these myths be distorted memories of real encounters with Earth's original inhabitants? Modern accounts add fuel to the mystery. Declassified military reports describe UFOs plunging into the ocean at impossible speeds, disappearing beneath the waves as if returning home. In 1997, the USS Trepang submarine allegedly recorded footage of a massive, unidentified craft maneuvering underwater near Antarctica, a location rife with rumors of Nazi bases and hidden tunnels. Even NASA's own sonar maps reveal unexplained cavities beneath Antarctica's ice, some large enough to house cities. And let's not forget the infamous USO phenomena, unidentified submersible objects that outpace naval vessels and defy known physics, suggesting technology not of this world. Or at least not of this surface. The most compelling evidence might come from geology itself. Massive underground ecosystems like the Movile Cave in Romania thrive in total darkness, powered by chemosynthesis rather than sunlight. If life can flourish in such extreme isolation, why not intelligence? The Earth's crust is honeycombed with unexplored caverns, some stretching hundreds of miles. The very low-frequency arrays used to detect nuclear tests occasionally pick up strange, rhythmic vibrations from these depth patterns that some researchers argue resemble coded signals. Are we hearing the echoes of machinery, the hum of a hidden society operating just beyond our reach? Skeptics dismiss cryptoterrestrials as conspiracy fodder, but the theory raises unsettling questions about our planet's history. If an advanced race did predate humanity, their relics wouldn't be on the Moon or Mars. They'd be buried under millennia of sediment, submerged under shifting oceans, or camouflaged to blend with natural rock formations. Every unexplainable artifact, like the 20,000-year-old grooved spheres of South Africa or the precision-cut tunnels in Turkey's Derinkuyu complex, could be fragments of a much larger puzzle. The ocean presents an even darker frontier. We've mapped Mars more thoroughly than our own seabeds. In 2012, a team filming near the Mariana Trench captured what appeared to be a colossal metallic structure vanishing into the abyss. Military submariners whisper of sonar contacts larger than whales moving at depths no organic creature could survive. Could these be the descendants of an ancient aquatic civilization, evolved to thrive in pressures that crush steel? Whether myth or reality, the cryptoterrestrial hypothesis forces us to reconsider humanity's place in Earth's timeline. We assume we're the pinnacle of evolution, the first to build and explore. But what if we're just the latest tenants, living atop ruins we don't recognize, while the original landlords watch silently from below? The truth might not be written in the stars, but etched in the bedrock beneath us, waiting for the day we dare to dig deep enough. We've been scanning the skies for radio signals, but what if extraterrestrial civilization stopped using radio waves eons ago? The galactic internet theory proposes something far more sophisticated, an ancient galaxy-wide communication network built not on clumsy electromagnetic waves, but on the precise beats of pulsars or the ghostly whispers of neutrinos. Picture a cosmic web stretching between stars, where messages travel via the universe's most reliable natural beacons or particles that barely interact with matter at all. Pulsars, rapidly spinning neutron stars, are nature's perfect lighthouses, emitting beams of radiation with metronomic precision. Some pulsars keep time more accurately than atomic clocks. An advanced civilization might encode data in these pulses, altering their rhythms subtly to transmit information across light years. The beauty of this system. It's self-powering and nearly indestructible. Unlike human-made satellites that degrade, pulsars will keep broadcasting for millions of years. SETI traditional searches focus on narrowband radio signals, but what if we're missing a library's worth of data hiding in plain sight, disguised as stellar phenomena? Then there are neutrinos, nearly massless particles that pass through entire planets as if they weren't there. While humans struggle to detect these elusive particles in massive underground tanks, a Type 2 or 3 civilization could use them as the ultimate stealth communication channel. Neutrino beams wouldn't scatter in interstellar dust or get absorbed by cosmic plasma. They'd arrive pristine from across the galaxy, carrying messages encrypted in their quantum states. The kicker, our current detectors can't distinguish artificial neutrino patterns from natural ones. We might already be bathed in interstellar telegrams, lacking the decoder ring to read them. This raises an uncomfortable possibility. SETI decades of silence don't prove aliens don't exist. They might just prove our technology is primitive. Imagine an ancient civilization tuning into Earth's early radio broadcasts. They'd hear disjointed snippets of Morse code and static, assume the planet lacked intelligent life, and move on. That could be exactly what's happening to us. The real traffic, high-bandwidth exchanges between civilizations might flow through channels we're only beginning to imagine. Astronomers have already stumbled onto potential fragments of this network. The repeating fast radio bursts FRB from distant galaxies with their enigmatic patterns have sparked debates about artificial origins. And in 2020, researchers discovered a strange, slow-spinning radio source dubbed ASCAP J173918.5 that defies known astrophysical explanations. Could these be relay stations or outdated nodes in a system whose architects are long gone? The most tantalizing clue lies closer to home. The Pioneer and Voyager probes carry golden records with sounds and images of Earth, a deliberate attempt at cosmic communication. But what if extraterrestrials left similar message-in-a-bottle artifacts embedded in pulsar signals or neutrino streams? The information might be there, waiting in the flicker of a dying star or the faintest ripple in a particle detector. If the galactic internet exists, its users wouldn't just be chatting, they'd be broadcasting knowledge, culture, and warnings on scales we can't fathom. The absence of obvious signals isn't emptiness. It's a sign we're still learning the alphabet of a language written in starlight and shadow. War isn't just a human tragedy, it could be a cosmic inevitability. The cosmic war survivors theory presents a chilling scenario. What if the universe's first civilizations didn't fade quietly into the night, but annihilated each other in conflicts so catastrophic they left the galaxy littered with ruins and relics? This isn't just speculative fiction. The Fermi Paradox's great filter, the hypothetical barrier preventing life from reaching interstellar scales, might not be a natural obstacle at all. It could be the grim aftermath of civilizations reaching a technological precipice and then using it to destroy themselves. Imagine two advanced societies competing for the same galactic resources, perhaps rare elements for their Dyson swarms or control over a neutron star's energy. Their weapons wouldn't be crude missiles or nukes, but something far more devastating: relativistic projectiles hurled at near light speed, turning planets into dust with kinetic force alone. They might deploy self-replicating nanobot swarms programmed to dismantle enemy infrastructure atom by atom, or black hole bombs, artificial singularities detonated to swallow entire star systems. The scars of such battles could still linger today. Astronomers have spotted stars with bizarrely high concentrations of heavy metals like gold and platinum, elements typically forged in supernova or neutron star collisions. Could these be the radioactive graveyards of civilizations that turned their suns into battlegrounds? The most unsettling evidence might exist right in our own backyard. The moon's surface is pocked with craters, but some formations defy easy explanation. The lunar swirls, bright, swirling patterns on the moon's surface, have magnetic properties unlike anything formed naturally. Then there's the so-called Moon's Tycho anomaly, a massive metallic object detected beneath the crater's surface by NASA, a gravity recovery and interior laboratory. Mainstream science attributes these to asteroid impacts, but what if they're remnants of ancient orbital defenses or shattered war machines? Even Earth bears potential scars. The Libyan desert glass, a field of yellow-green silica fragments scattered across the Sahara, appears to have been formed by an intense, sudden heat event some 29 million years ago. Natural explanations exist, but the glass's purity and distribution eerily resemble the aftermath of a theoretical nuclear exchange or directed energy weapon test. This theory's darkest implication isn't just about ruins, it's about patterns. If civilizations consistently destroy themselves upon reaching a certain technological threshold, then humanity's own trajectory becomes a ticking clock. The Great Filter might not lie ahead of us, guarding the path to galactic exploration. It could be behind us, a silent specter waiting for us to stumble into the same fatal mistakes. Every unexplainable cosmic anomaly, every gap in the archaeological record, might not be evidence of absence, but of a universe where intelligence is its own worst enemy. Yet there's a sliver of hope in the silence. If ancient wars ravaged the stars, the fact that we haven't found definitive proof could mean something survived, not just the weapons but the wisdom. Perhaps a handful of civilizations, having barely escaped annihilation, now enforce a galactic quarantine, suppressing dangerous technologies before young species like ours can weaponize them. Or maybe the ruins themselves are warnings left by the last survivors of a war so total it sterilized entire spiral arms. The universe doesn't forget. And if we're listening, its scars might still have stories to tell. Entropy is the universe's inescapable fate, the slow unraveling of all order into chaos, the heat death that awaits every star, every galaxy, every atom. But what if the universe's first civilizations found a way to cheat this cosmic expiration date? The entropy defiers theory dares to imagine societies so advanced they didn't just delay the inevitable. They bent the fundamental laws of physics to their will, turning the universe's march toward disorder into an illusion they could control. At its core, entropy is a measure of chaos. The second law of thermodynamics states that in any closed system, disorder must always increase over time. Stars burn out, structures decay, and even black holes eventually evaporate into nothingness. But what if a civilization discovered how to reverse this process, creating pockets of negative entropy where energy flows backward and complexity rebuilds itself? The math isn't entirely science fiction. Nobel Prize-winning physicist Ilya Prigogine demonstrated that certain systems far from equilibrium, like living organisms, can temporarily defy entropy by exporting disorder to their surroundings. Scale this principle up with technologies we can't yet fathom, and you might have the blueprint for immortality. One pathway could involve negative energy, a hypothetical form of matter with repulsive gravity. Einstein's equations allow for its existence, and quantum field theory suggests it might lurk in the vacuum of space itself. If harnessed, negative energy could stabilize wormholes, creating shortcuts in spacetime that bypass entropy's grip. Imagine a civilization that doesn't just build megastructures, but rewires the fabric of reality, stitching together regions of the cosmos where time runs backward or energy replenishes itself. Their cities wouldn't just endure, they'd regenerate, like a cosmic phoenix rising from its own ashes. Even more radical is the idea of Boltzmann brains adapted for engineering. If self-aware structures can spontaneously emerge from quantum fluctuations, as the Boltzmann brain hypothesis suggests, why couldn't a civilization design systems that exploit this? Picture quantum-scale machines programmed to reassemble dissipated energy into usable order, like an army of microscopic Maxwell's demons tirelessly sorting chaos back into structure. The universe's heat death wouldn't be an end, just a temporary state awaiting their intervention. Evidence for such civilizations might be hiding in the cosmic background. The universe's expansion is accelerating, driven by mysterious dark energy. But what if this isn't a natural phenomenon? Some theorists suggest it could be the residual signature of entropy reversal experiments gone awry, or worse, a warning. If a civilization tampered too aggressively with the cosmos's fundamental rules, their failures could have etched themselves into the universe's expansion, a cautionary scar written in the stretching of space-time itself. The most haunting question isn't whether reversing entropy is possible, it's what happens to those who try. Immortality might come at a price beyond our comprehension. A society that masters eternal order could find itself trapped in a static, timeless void where change becomes impossible and innovation ceases. Or perhaps the defenders of entropy, natural law's cosmic immune system, wait to erase any civilization reckless enough to challenge the universe's balance. The silence we observe might not be the absence of others, but the aftermath of their ambition. Yet the entropy defiers leave us with a paradoxical hope. If intelligence can outlast the stars, then the universe's first masters might still be here, not as physical beings, but as patterns woven into the quantum foam, their thoughts resonating in the vibrations of strings we can't yet measure. Their legacy wouldn't be ruins or artifacts, but the faint, persistent whisper of order in the dark, proof that even the universe's coldest laws are negotiable for those who dare to rewrite them. What if the most advanced civilizations don't just exist somewhere in the universe, but everywhere and nowhere at once, caught in a cosmic game of quantum hide and seek? The quantum immortals theory takes one of physics' most bewildering concepts, superposition, and stretches it to mind-melting extremes. Imagine a civilization so sophisticated it can manipulate quantum mechanics not just in labs but on the scale of entire societies. These beings wouldn't live or die in the traditional sense. Instead, they'd exist in a ghostly state of both, their fate undecided until some observer, perhaps even us, pulls them from the fog of possibility into concrete reality. This isn't just wild speculation. The roots of the idea trace back to Schrödinger's infamous cat, the thought experiment where a feline in a box is simultaneously alive and dead until someone peers inside. Quantum suicide, a darker variation, suggests a conscious observer could never witness their own death because their continued observation would collapse reality into timelines where they survive. Now scale that up. What if an entire civilization engineered itself into a similar state, using quantum trickery to evade extinction? Every possible outcome, their flourishing, their collapse, even their never having existed at all, would remain equally real until an outside force chooses one. Evidence for such a civilization might lurk in the universe's most confounding anomalies. Take quantum entanglement, where particles instantaneously influence each other across vast distances. Could this phenomenon be more than random physics? perhaps fragments of a vast, engineered network with entire cultures entangled across light years, their survival probabilistically linked. Even stranger are the cosmic voids, vast, empty regions of space where galaxies should exist but don't. Mainstream cosmology blames dark energy, but what if these are zones where a civilization's superposition collapsed into non-existence, leaving behind a blank spot in the cosmos like a deleted file in the universe's hard drive? The eerie implication: we might be unwitting participants in their experiment. Every time astronomers train a telescope on a distant star, they could be forcing a quantum civilization to choose a definitive state, freezing one potential history into permanence while erasing countless others. It's as if the universe is less a stage and more a script with infinite rewrites, where ancient beings linger in the margins, waiting for their cue to step into the light or fade into oblivion. But the most unsettling question isn't whether this is possible, it's whether we're already entangled in their game. If consciousness plays a role in shaping reality, as some interpretations of quantum theory suggest, then our search for extraterrestrials could itself be the trigger that solidifies their existence. The universe's first civilizations might not be lost to time. They could be all around us, neither here nor there, watching from the quantum shadows until the moment we finally think to look. Imagine a civilization so voracious for knowledge that it dismantles stars not just for energy, but to build the ultimate thinking machine. This is the staggering vision of the Matryoshka brain, a hypothetical megastructure that puts even Dyson spheres to shame. Picture a series of nested shells encircling a star, each layer harvesting waste heat from the one above it, creating an unfathomably powerful computational network. The innermost shell, blazing at star-hot temperatures, handles the most intensive calculations. Further out, cooler layers perform simpler tasks, until the outermost, radiating barely more than the cosmic background, serves as long-term storage. Together, they'd form a single, star-sized supercomputer capable of running simulations on scales we can barely comprehend. Now take this concept to its chilling extreme. If a civilization built such a brain around every star in its galaxy, linking them into a galaxy-spanning neural network, what couldn't it simulate? Entire universes with their own laws of physics. Timelines branching endlessly like fractal roots, civilizations rising and falling in microseconds, unaware they're just fleeting thoughts in a greater mind. The processing power would be godlike enough to recreate every atom, every conscious moment of our own cosmos down to the quantum foam, which raises the unsettling question: are we living inside someone else's Matryoshka simulation? The math behind this is both tantalizing and terrifying. A single star's energy output, efficiently harnessed, could sustain 10 to the 38 operations per second, enough to simulate billions of human lifetimes in the blink of an eye. Scale that across a galaxy's worth of stars, and you're looking at computations so vast they could model entire multiverses. Some theorists argue this explains our universe's suspiciously life-friendly constants. The precise balance of gravity, the cosmological fine-tuning that allows atoms and galaxies to form. These might not be cosmic luck, but parameters deliberately set by the engineers running the simulation. But here's where it gets truly strange. If our universe is a simulation nested within another, what's stopping that parent universe from being a simulation too? The chain could stretch back infinitely, layers upon layers of reality, each running on the cold logic of some higher civilization's computation. Every glitch, every unexplained quantum anomaly, from particles popping in and out of existence to the eerie way measurements seem to shape reality, could be artifacts of this cosmic code. The double-slit experiment, where light behaves as both particle and wave until observed, feels disturbingly like a rendering optimization. Why calculate the precise state of something until a conscious being looks? Evidence might already exist in the fabric of our universe. Physicists have discovered mathematical symmetries and patterns so precise they seem engineered. The universe operates on binary yes/no principles at the quantum level. Even the speed of light could be a processing limit, the maximum clock speed of the cosmic computer. The pixelation theory suggests that at the tiniest scales, space-time itself might be digital, composed of discrete Planck-length units like a video game's voxels. These aren't just curiosities, they're potential fingerprints of the architects, yet the most profound implication isn't about our potential simulated status, it's about purpose. Why would a civilization build such a thing, perhaps as an archive preserving every possible version of reality, or as an experiment testing ethical or technological dilemmas in infinite variations? Or maybe for something beyond our comprehension, a form of cosmic art, where universes are canvases and physics the brushstrokes. The creators themselves might have forgotten the original intent, lost in recursive layers of their own making. Whether nightmare or revelation, the Matryoshka brain theory forces us to confront a humbling duality. We could be both the pinnacle of our own reality and mere background processes in another's. The cosmos doesn't need to be silent for us to feel small, just infinitely deeper than we ever imagined. And somewhere in that depth, the first builders might still be watching, not through telescopes but through lines of code we're only beginning to decode. What if the greatest civilizations in the universe don't live on planets at all, but spend eternity sailing the cosmic ocean aboard colossal arcs, each generation born and dying in the void between stars? The light-speed nomads theory rewrites the rules of interstellar life, imagining cultures so committed to exploration they've turned their entire societies into restless wanderers, forever chasing the horizon of the next habitable world. These wouldn't be the sleek starships of science fiction, but mobile ecosystems, artificial worlds with forests, lakes, and cities encased within rotating hulls, powered by the faint starlight they intercept during their endless journeys. Picture a vessel the size of Manhattan, its interior lit by artificial suns, where descendants of the original crew have lived for so long they've forgotten any home but the ship itself. Their myths might speak of a blue planet their ancestors fled millennia ago, its name reduced to a half-remembered legend. Their entire culture would revolve around maintenance and survival, treating the ship not as a vehicle, but as a sacred being that sustains them. Every rivet and circuit would hold religious significance, every repair ritualized like surgery on a living god. But relativity imposes cruel limits on their dreams. Even at near light speeds, crossing the galaxy would take tens of thousands of years, time enough for civilizations to rise and fall within the ship's corridors. Communication with other nomads would be a dialogue of ghosts. Messages sent outward might take centuries to reach recipients who have long since perished or evolved beyond recognition. The cosmos would become a vast, echoing museum where every signal, every artifact is a relic of someone else's past. Some theorists propose an even more radical adaptation, abandoning physical form altogether. If matter can't breach light speed, perhaps consciousness can. A civilization might transfer their minds into photons, becoming beams of coherent light that race across galaxies at the universe's speed limit. To these beings, time would dilate to near stillness. Their subjective experience of a 1,000-year voyage might feel like an afternoon stroll. They'd perceive the cosmos in ways we can't fathom. Gravity wells as eddies in a stream, supernova as sudden flares in their path. Communication would happen through quantum entanglement, instant and unbreakable, binding their diaspora together across light years. Yet the price of such freedom is isolation. Light-based life couldn't land on planets or interact with solid matter. They'd become specters, forever flitting through a universe they can no longer touch. Stars might be their way stations where they pause to harvest energy before darting onward, their very existence a flicker against the dark, the heartbreaking irony. These nomads could be all around us. A generation ship might have drifted through our solar system 1,000,000 years ago, its inhabitants oblivious to the primates gazing up at their hulls' reflected light. Photonic beings could be bathing Earth right now, their signals indistinguishable from the cosmic background. In a universe this vast, the greatest civilizations might not be the ones who conquer space, but those who embrace the endless journey, knowing they'll never see home again. What if the universe's first civilizations weren't engineers or conquerors, but artists, sculpting reality itself into grand expressions of beauty and meaning? The cosmic artist's theory paints a breathtaking vision. Ancient beings who treated galaxies as their medium, weaving intricate designs into the fabric of spacetime, not for survival or power, but purely for the sake of creation. Imagine a culture so advanced that their greatest achievements weren't Dyson spheres or quantum computers, but celestial masterpieces meant to endure for eons, waiting for younger species like us to stumble upon them and marvel. Look up at the night sky, and you'll find their potential handiwork hiding in plain sight. Nebulae like the Butterfly Nebula or the Whirlpool Galaxy aren't just chaotic stellar nurseries, they're uncannily precise fractal patterns, repeating geometric shapes at every scale like a cosmic fingerprint. Science explains these as natural phenomena, the result of gravity and turbulence. But what if their perfection runs deeper? Fractals appear throughout human art, from the spirals of Hindu mandalas to the recursive arches of Islamic mosaics, because they resonate with something primal in our perception. If another civilization shared this instinct, might they have encoded their vision into the stars themselves? The Orion mystery offers a tantalizing clue. The three aligned stars of Orion's belt mirror the precise layout of Egypt's Giza pyramids, a correlation some researchers dismiss as coincidence. Yet the pyramids aren't alone. From the Nazca lines to Cambodia's Angkor Wat temples, ancient sites across Earth seem obsessed with mirroring constellations. Could this be more than worship? Might it be an attempt by early humans to answer an artistic message left in the sky millennia before, like children scribbling in the margins of a masterpiece they don't yet understand? The most compelling evidence lies in the inexplicable. Take the Great Attractor, a gravitational anomaly dragging thousands of galaxies toward it at 22 million kilometers per hour. Mainstream cosmology attributes this to a massive concentration of dark matter, but its precise alignment with our local galactic plane feels eerily deliberate, like the focal point of some gargantuan sculpture. Even pulsars, those cosmic metronomes, occasionally emit rhythms that mirror prime numbers or geometric sequences. SETI has long considered such patterns the hallmark of artificial signals, but what if we've been mistaking art for communication? This theory flips the conventional search for ancient aliens on its head. Instead of scanning for broken megastructures or coded radio bursts, we might need to train our telescopes like curators in a gallery, searching for aesthetics where we expected engineering. The universe's most enduring legacies could be compositions of light and gravity, meant not to convey information but to evoke wonder. After all, what better way to transcend time than to create something so beautiful that every civilization who finds it pauses, just for a moment, to share in the artist's vision across the abyss of ages? The haunting question isn't whether these artists exist, it's whether we're alone in appreciating their work. The cosmos might be filled with masterpieces no one has yet admired, their splendor unfolding in the slow dance of colliding galaxies or the delicate spin of quantum foam. And if we're the first to notice, that makes us something far more than observers. We become the audience the creators always hoped would one day arrive. What if the reason we can't find ancient civilizations isn't because they're hidden in space, but because they exist in dimensions we can't perceive? The dimension hopper's theory takes the search for cosmic ancestors into uncharted territory, proposing that the universe's first intelligences didn't evolve in our familiar three-dimensional reality at all. Instead, they might have flourished in higher spatial dimensions. Their existence as invisible to us as a shadow is to the object casting it, until they choose to intersect with our world in ways that seem like magic or miracles. String theory, the framework suggesting the universe has up to 11 dimensions, provides the scientific scaffolding for this mind-bending idea. In this model, our three-dimensional universe could be just one brain, short for membrane, floating in a higher dimensional space, like a sheet of paper suspended in a vast ocean. Other brains with their own physics and civilizations might drift within microns of ours in these extra dimensions, yet remain forever separated by a barrier we can't cross. But just as a pencil can pierce through multiple sheets of paper, certain phenomena might momentarily bridge these dimensional divides. Ancient accounts of gods descending from the heavens or vanishing into thin air start to take on new meaning when viewed through this lens. Historical oddities gain fresh significance under this theory. Consider the Nazca lines once more, those massive geoglyphs only fully visible from high above. What if they weren't meant for beings in aircraft, but for observers looking down from a fourth spatial dimension, able to perceive the entire design simultaneously without needing altitude? Similarly, the sudden appearance and disappearance of figures in biblical texts like Ezekiel's wheel or Hindu stories of the Vimanas might describe fleeting intersections with higher dimensional travelers, their movements appearing impossible by our physical laws. Modern physics experiments have stumbled onto potential evidence. At the Large Hadron Collider, researchers occasionally detect particles with missing energy momentum that seems to vanish into nowhere. While most scientists attribute this to neutrinos or calibration errors, some theorists speculate these anomalies could be particles briefly interacting with higher dimensions before slipping back into their native space. Even dark matter's gravitational effects might be the shadows of fourth-dimensional structures brushing against our universe, their full forms as incomprehensible to us as a cube would be to a two-dimensional being. The implications rewrite our cosmic search parameters. Instead of scanning exoplanets for radio signals, we might need to hunt for gravitational anomalies or quantum disturbances that hint at intelligence operating in extra dimensions. Civilizations there wouldn't build Dyson spheres. They might manipulate reality by folding space in ways we can't visualize, turning entire stars into origami-like structures visible only as bursts of inexplicable energy. Their relics wouldn't be buried on planets, but imprinted in the fabric of space-time itself, waiting for us to develop the mathematical eyes to see them. But the most profound revelation isn't just that higher dimensional beings could exist, it's that they might be trying to communicate. Mathematics could be their universal language, with patterns in prime numbers, fractal geometry, or even the precise constants of physics serving as cosmic signposts. The golden ratio appearing in everything from seashells to galaxies, the uncanny elegance of Euler's identity. These might not be happy accidents, but deliberate markers left by civilization saying, "We were here." The universe's first masters may not be lost to time or space, but hovering just beyond the edges of our perception, waiting for the day we finally grasp the full dimensions of their existence. What if the universe's oldest civilizations found a way to mine the very fabric of reality for energy, not from stars or black holes, but from the seething quantum foam of empty space itself? The vacuum energy harvester's theory proposes a staggering possibility. Advanced beings might have tapped into zero-point energy, the boundless power hidden in the vacuum of space-time, leaving behind eerie voids as evidence of their experiments. This isn't science fiction, it's grounded in real physics, and the implications rewrite everything we assume about cosmic archaeology. At the quantum level, there's no such thing as true emptiness. Even in a perfect vacuum, particles flicker in and out of existence like cosmic static, their energy bubbling beneath the surface of reality. This zero-point energy isn't just a theoretical curiosity. It's a potential power source so vast that a single cubic centimeter of empty space could contain more energy than all the matter in the observable universe. The catch, harnessing it would require technology capable of bending quantum fields like putty, something far beyond our current grasp. but for a civilization billions of years ahead of us, it might be as routine as lighting a candle. The smoking gun for such feats could be lurking in unexpected places, patches of space-time that are too empty. Astronomers have mapped strange cosmic voids, regions where galaxies are inexplicably scarce, like bubbles in the foam of the universe. While most attribute these to the uneven distribution of matter after the Big Bang, some theorists speculate they could be scars left by zero-point energy extraction. Picture a civilization stabilizing quantum fluctuations in a localized area, siphoning energy until the vacuum itself is drained, leaving behind a void that refuses to refill. These wouldn't be natural structures, but industrial byproducts on a galactic scale. On Earth, we've already glimpsed the underlying mechanics in miniature. The Casimir effect, demonstrated in labs since the 1950s, occurs when two metal plates placed nanometers apart in a vacuum are pushed together by the sheer pressure of quantum fluctuations outside them. It's as if the vacuum itself is alive with force, and if you can create asymmetry in that energy, you can extract work from nothingness. Now imagine scaling this principle to cosmic proportions. A sufficiently advanced society might construct quantum sieves, vast arrays of exotic matter that strain energy from the vacuum like gold from riverbeds. The energy harvested could power civilizations for eons without the need for stars or fuel. But here's the twist: zero-point extraction wouldn't just leave voids, it could distort the very laws of physics in its wake. Einstein's equations tell us energy and space-time are intertwined. Tampering with one warps the other. Regions where vacuum energy was heavily harvested might exhibit bizarre gravitational lensing, bending light in ways that defy conventional models. Some astronomers argue this could explain anomalies like the cold spot in the cosmic microwave background, a vast, unusually empty region that behaves like a bruise on space-time. And then there's the dark matter connection. If dark matter is a quantum field permeating the cosmos, as some theories suggest, vacuum engineers might have learned to manipulate it directly, using it as a scaffold for their energy grids. The strange distribution of dark matter halos around galaxies could be the fossilized infrastructure of these projects, their original purpose lost to time. The most unsettling implication isn't just that civilizations might have mined the vacuum, it's what happens when they're done. A universe where zero-point energy is exhaustible would eventually become a patchwork of depleted zones, like a honeycomb drained of its nectar. Could this be the grim fate awaiting all advanced life? Not a fiery apocalypse, but a slow suffocation as the quantum wells run dry. Or perhaps the harvesters found a way to move on, leaving behind exhausted realities for fresher ones, a cosmic succession plan written in the voids between stars. For now, these ideas linger at the edge of physics and speculation. But every unexplained void, every anomaly in the dark energy surveys, could be a breadcrumb leading back to the universe's first energy revolutionaries. The beings who didn't just reach for the stars, but learned to drink from the emptiness between them. The Boltzmann savant's theory takes the mind-bending concept of Boltzmann brains and flips it on its head. What if these momentary flickers of consciousness didn't just emerge alone in the void, but briefly connected, forming intricate networks of thought that behave like ephemeral civilizations? Imagine not just one self-aware quantum fluctuation, but millions of them spontaneously arising in close proximity, their fleeting existences overlapping just long enough to exchange ideas, build temporary societies, and then vanish back into the cosmic noise before the universe even notices they were there. These wouldn't be civilizations of bricks and mortar, but of shared hallucinations, collective dreams conjured from the randomness of space-time itself. Picture a group of Boltzmann brains appearing simultaneously near a black hole's ergosphere, where the fabric of reality churns with quantum turbulence. For the briefest instant, their perceptions synchronize, creating a shared illusion of a world with rules, history, even culture. One mind might perceive itself as a scientist in a lab, another as an artist sculpting starlight, yet another as a philosopher questioning the nature of their own existence. Together, they weave a fragile tapestry of meaning, unaware that their entire society is just a statistical hiccup in the vacuum. The terrifying beauty of this idea lies in its implications for our own reality. If Boltzmann collectives can emerge from chaos, how do we know our universe isn't the elaborate shared hallucination of such a group, a grand cosmic thought that's already fading? The laws of physics, the constellations above us, even our memories of yesterday could just be the intricate details of a story these savants are telling themselves to make sense of their nanosecond of awareness. Their history might be nothing more than a desperate attempt to impose narrative order on randomness before the curtain falls. Evidence for this could be hiding in the fine-tuning of our universe. The precise balance of physical constants that allow for complexity, the strength of gravity, the mass of electrons have long puzzled scientists. Some call it the anthropic principle, others see the fingerprints of design. But what if it's neither? What if these laws are simply the shared assumptions of the Boltzmann savants, the internal logic of their collective dream? A lone Boltzmann brain might imagine a nonsensical universe, but a network of them could stabilize into a consistent illusion through mutual observation, like a group of sleepers unknowingly shaping the same lucid dream. This leads to a haunting paradox. The more coherent and stable our universe appears, the more likely it could be a Boltzmann construct. Think of how dreams feel real while we're in them. Only upon waking do we notice the inconsistencies. If we ever discover a fundamental contradiction in physics, some irreducible glitch in the matrix, it might be the moment our universe's dreamers start to stir. Until then, the unsettling truth is that we'll never know for sure. The Boltzmann savants wouldn't leave ruins or artifacts, just the faint statistical aftertaste of their brief, brilliant thought experiment in the quantum foam. And if that's the case, the greatest cosmic joke is that we're not the archaeologists of ancient civilizations, we're the fleeting dream of a civilization that never truly existed at all. The universe might not be empty, just lethally silent. The dark forest dwellers theory takes its name from a chilling sci-fi metaphor. Imagine the cosmos as a vast, pitch-black woodland where every civilization is a hunter hiding among the trees. The moment one reveals its location, by lighting a fire, by shouting it's targeted and destroyed, this isn't just fiction. Some scientists argue it could explain why we haven't heard from advanced societies. They've learned that survival means never, ever announcing your presence. Humanity's relentless broadcasts into space suddenly seem reckless under this lens. Since the 1930s, our radio, TV, and radar signals have been leaking into the cosmos, forming an ever-expanding bubble of noise that now stretches over 100 light-years. SETI deliberate attempts at contact, like the Arecibo message beamed toward a star cluster in 1974, might read less like friendly greetings and more like a toddler waving a flashlight in a sniper's scope. Even our planet's biosignatures, oxygen, methane, the spectral fingerprint of chlorophyll, could be a neon sign screaming life here to any civilization with telescopes slightly better than ours. The logic behind the dark forest is brutally simple. Resources in the universe are finite. Intelligence evolves through competition. Any civilization that grows powerful enough to threaten others becomes a target. The only winning move is stealth. This might explain the eerie absence of Dyson spheres or megastructures we'd expect from advanced societies. They'd be too visible. Instead, civilizations might cluster around dim red dwarfs, their energy needs met by subtle, undetectable means. Some theorists speculate they could even dismantle their own outer planets quietly, spreading the debris to mimic natural asteroid belts, leaving no trace of their engineering. But the darkest twist, the dwellers might already be here. If hiding is paramount, the best strategy isn't just silence, it's controlled observation. Earth could be surrounded by monitoring probes so advanced they're indistinguishable from space dust or cosmic rays, reporting back on our technological progress. The moment we approach a certain threshold, maybe artificial superintelligence, maybe relativistic weapons, they might strike preemptively, not out of malice but cold Darwinian calculus. Our history books are filled with quieter examples. Indigenous tribes wiped out by diseases they'd never encountered, ecosystems collapsing from invasive species. The dark forest generalizes this to a cosmic scale. Not everyone finds this apocalyptic vision convincing. Critics argue it projects human paranoia onto alien psychology. A civilization surviving long enough to master interstellar travel would likely have outgrown resource wars, just as modern Earth sees fewer conflicts over water or farmland than medieval societies did. Others point out that stealth is impossible over geological timescales. Any civilization could eventually detect another's waste heat or gravitational disturbances. The theory also struggles with coordination. In a forest with billions of hunters, sooner or later, someone would break the silence. Yet the debate forces a vital question: are we being naive? The dinosaurs didn't go extinct because they offended the asteroid. They just happened to be in its path. Cosmic threats don't need motives. Whether the danger comes from berserker probes left over from ancient wars or a civilization interpreting our signals as a viral AI about to escape into the galaxy, the outcome is the same. The dark forest isn't a warning about aliens, it's a mirror, reflecting back humanity's own unhealed scars of distrust and first-strike instincts. Perhaps the most unsettling possibility isn't that the forest is dark, but that we're the ones who have been shouting into it, unaware that everyone else stopped talking billions of years ago. Our radio bubble might not be a dinner bell for predators, just the last, lonely echoes in a graveyard where all the other civilizations learned to hold their breath. What if the universe's final act isn't a cold, silent fade, but a resurrection so grand it brings back every being who ever lived? This is the spine-tingling promise of the Omega Point theory, where physics and theology collide in a vision of the far future so radical it borders on prophecy. Proposed by physicist Frank Tipler, the idea hinges on a staggering premise. As the cosmos races toward its end, a superintelligent civilization could harness the collapsing universe's energy to perform the ultimate miracle, recreating every consciousness that ever existed, from ancient alien philosophers to forgotten human poets, in a final, infinite moment of cosmic clarity. The mechanics sound like something ripped from a sacred text. In Tipler's model, as the universe approaches the Big Crunch, a hypothetical collapse mirroring the Big Bang, its contraction would generate unfathomable energy densities. A civilization advanced enough to ride this tsunami of spacetime could use it as fuel for computations of unimaginable scale, simulating every possible configuration of matter and energy that ever was. Every laugh, every sunset, every thought that flickered into existence across billions of years would be recreated with perfect fidelity, not as copies but as continuations. It's as if the universe itself becomes a self-resurrecting machine, turning its death throes into a recursive loop of remembrance. The theological undertones are impossible to ignore. Tipler's Omega Point deliberately echoes philosopher Pierre Teilhard de Chardin's concept of a divine endpoint where all consciousness converges. But this isn't mysticism, it's grounded in the physics of closed universes and quantum information theory. The key lies in the Bekenstein bound, which states that a finite region of space can contain only a finite amount of information. As the universe contracts, this limit would allow an ultimate civilization to gather and process every bit of data the cosmos ever produced, effectively backing up reality before the end. Critics pounce on the theory's speculative leaps. Modern cosmology overwhelmingly favors an expanding universe ending in heat death, not a big crunch. Even if contraction were possible, the energies involved would likely vaporize any structure, no matter how advanced, and the computational requirements for resurrecting every sentient being in history. They'd make a Dyson sphere look like a toy, but Tipler counters with a provocative thought. If intelligence can survive until the universe's final moments, it could manipulate the very laws of physics to ensure its own preservation, rewriting the rules of reality like a programmer debugging code at the last second. The most haunting question isn't whether the omega point is possible, it's what it implies about our present. If every thought and action is destined to be replayed in that final singularity, then every choice carries eternal weight. A kindness shown today, a discovery made tomorrow, could echo in that infinite now. The theory twists time into a loop where the far future reaches back to sanctify the past. It's a vision both humbling and exhilarating, that in the universe's dying breath we might all wake up together, blinking into the light of a second chance written in the stars themselves. What if the story of human origins isn't just written in our genes but by them? The cosmic ancestors theory weaves together threads from across these 30 concepts into one spine-tingling possibility. We might be the living legacy of an ancient civilization's deliberate design. Not as their equals or their heirs, but as their experiment, a biological message in a bottle floating through time until we're advanced enough to decode our own creation. Consider the eerie precision of DNA. This molecule doesn't just build life, it stores information with a density that dwarfs our best hard drives. A single gram can hold 215 petabytes of data. Yet our genomes are filled with so-called junk DNA, stretches of code with no known biological function. Mainstream science attributes this to evolutionary debris, but what if it's something far stranger? In 2013, researchers at the University of Washington encoded an entire book into synthetic DNA, proving its potential as a cosmic USB drive. If humanity can do this after mere decades of genetic engineering, what could a billion-year-old civilization achieve? The clues might be hiding in plain sight. Take the FOXP2 gene, often called the language gene. Its mutation roughly 200,000 years ago coincides with humanity's sudden leap in complex speech, a divergence so sharp some biologists call it biological teleportation. Then there's HL1, a segment of human DNA that evolves 100 times faster than other regions, as if being aggressively rewritten. These aren't just random mutations. They're the fingerprints of something intentional, like a programmer optimizing code for a specific outcome. But the most tantalizing evidence lies in our shared biology. Across all Earth life, from bacteria to blue whales, the genetic code uses the same 64 molecular words to translate DNA into proteins. This universal language suggests a common origin. But why would evolution converge on exactly this system unless it was imposed? Some researchers argue this isn't just unlikely, it's statistically impossible without outside influence. The cosmic architects might have seeded Earth with a biological starter kit, ensuring all life would speak the same genetic dialect for easier observation or eventual communication. This raises a chilling question. If we're an experiment, what's the purpose? One possibility is that DNA itself is a time capsule. Civilizations facing extinction might encode their knowledge into synthetic genomes, launching them aboard meteorites or directed panspermia probes. Our bodies could literally carry their history, our cells ticking like alarm clocks set to awaken when we develop the tools to read them. Projects like the Human Genome Archaeology Initiative already screen non-coding DNA for mathematical patterns or repeating sequences that mimic prime numbers, hallmarks of artificial design. Yet the darkest interpretation isn't about the past, it's about the future. Ancient beings might not just have left a message, they could have written the delivery instructions. The rapid acceleration of human technology, from stone tools to AI in a geological blink, could be part of the script, a trigger coded into our DNA to ensure we reach a stage where we can respond. Like a cosmic voicemail waiting for playback, our genome might hold the key to contacting its creators or revealing why they vanished. As we stand on the brink of editing our own DNA with CRISPR and quantum biology, we're not just unlocking life's secrets, we might be fulfilling an ancient mandate. Every genetic breakthrough could be another step toward a rendezvous with the architects of our existence. And when that day comes, the greatest discovery won't be that we're not alone, but that we never were. From the precursors who may have mastered the cosmos billions of years before Earth formed, to the Boltzmann savants flickering in and out of existence like quantum fireflies, these 30 theories don't just expand our idea of ancient civilizations. They shatter it entirely. Each one peels back another layer of assumption, revealing possibilities that challenge not only where we look for life, but what life even means. Time becomes fluid under the gaze of time-traveling founders. Biology transcends flesh in the visions of plasma-based beings, and the very fabric of reality warps in the hands of dimension hoppers. Think about how fundamentally these ideas reshape our place in the universe. If cryptoterrestrials walk among us or post-biological minds hum in the quantum void, then humanity isn't the pinnacle of intelligence. We're newcomers stumbling onto a stage already crowded with actors we can't see. The cosmic gardener's theory turns planets into incubators. The dark forest warns that survival might require silence, and the Omega Point dares to suggest that every thought we've ever had could echo eternally in the universe's final moments. These aren't just stories, they're mirrors forcing us to question whether our science, our history, even our reality might be built on foundations we don't yet understand. Consider the patterns that tie them all together, the recurring themes of transcendent civilizations leaving their bodies behind to become light or data or thought itself. The obsession with communication, whether through pulsar signals, genetic codes, or gravitational ripples, and above all, the haunting silence that lingers at the heart of each theory, a reminder that the universe owes us no answers. Yet within that silence lies the most thrilling possibility of all, that we're standing at the edge of discoveries that could rewrite everything. The next telescope, the next lab breakthrough, the next ancient artifact unearthed, any one of them might hold the key to proving that we're part of a story far older and far stranger than we ever imagined. So stay curious, look up at the stars and wonder if they're engines or art or eyes watching back. Question the gaps in our history, the anomalies in our genes, the glitches in our physics. Because the greatest lesson these theories teach isn't about aliens or ancient gods, it's that the universe thrives on mystery. And the day we stop being surprised by it is the day we stop truly seeing it at all. The cosmos didn't put limits on wonder, neither should we.